So people realize that.
Yeah, exactly. Three and 4 years now. It's guaranteed the week of the boot count for anything, regardless of time of year. There would be anywhere from 2 to 5 tornadoes in that first. Within like a 2-hour driving distance of the front. And it's like this, and we left the first out of the bus leaving this week, so work it down and try out. Albert testing over those weeks. May 5th. I have a livestock. Outbreak no sound. Oh, I remember one. It's like, it's snow today.
Next semester.
I haven't had a chance to go look at it yet. I'm putting the radar lab. I worked on some stuff. Still might come from
So like
because a lot of
other than maybe changing
I put 120 right.
I saw this one.
But that came up because I asked him a question yesterday about the radar lab.
That's what I was thinking. Last night I was so These are why I saved that.
Don't stand still for
Okay, welcome to new semester of Weather Watch. For those of you that are unfamiliar with this is a discussion of the past week's weather, current weather, and future weather, and we certainly welcome students leading these discussions. Professor Martin should be joining us shortly. Today, I'll get started, and we'll go through this. And Kelton, did you have something you wanted to show on current weather?
I was just talking earlier about there was a heavy snow band that went through Chicago, but I was just discussing the radar signature about it.
Okay.
How much snow did you say?
6 to 8 inches thus far.
It was a very narrow band that just went right through the area.
Okay, I hadn't had a chance to actually even look at current weather. I've been focused on things.
You can actually see it on the watch and warning map.
Yeah, right there. So, so in fact, when we get to some of the current weather, if you wanted to say something or there are particular links we should go to, please let us know. We can take a look at that. Again, this is very informal. We welcome questions, comments, folks that are on the internet joining us. Also, this is recorded, so you can go back and look at it on YouTube as well. So, we'll just get started. Today's Weather Watch focus, I think, is going to be primarily on an event that's about to unfold along the east coast of the United States. There's still some uncertainties associated with this particular event, but it's a significant winter storm that's going to be characterized by a rapidly deepening cyclone developing just offshore, moving northward toward Cape Hatteras, but east of Cape Hatteras, and then a collection of cyclones that develops just south of southern New England, and it's the evolution of that set of cyclones and the vorticity associated with it that's going to play a role on which parts of the East Coast are going to get significant snowfall. Some of the numerical weather prediction models this morning and late last night were forecasting upwards of close to 3.5 feet of snow in some places associated with this. With this rapidly deepening cyclone deepening over 50 millibars over the next 24 hours, there's also the possibility, or there will be likelihood of very intense winds. And so with those intense winds, with heavy snowfall rates, those will reduce visibilities to beneath a quarter of a mile for extended periods of time. As a consequence, the Weather Service offices from the Delmarva Peninsula all the way up to down East Maine have blizzard warnings in effect. So for a blizzard, you don't need to have snow falling, you just need to have snow falling or blowing snow that reduces the visibility to beneath a certain criteria for an extended period of time. And so that's what's going to be occurring here. But the snow will fall fast and furiously across much of the East Coast and offshore. Winter storm watches, or winter weather advisories, extend in these light blue areas. The purple areas are where we have winter storm warnings. And then because of the uncertainty into the exact track of this cyclone and where the snow bands are going to set up, winter storm watches go all the way from western Massachusetts, Northampton area, all the way up into northern Maine. And so it's going to be of considerable interest to see how this unfolds. Also, welcome, John. I don't know if you wanted to do any of the current weather. I was just setting up the
I can do some of that, yeah.
picture. Okay.
We're getting the band back together.
Yeah. Welcome back, John, after a sabbatical.
Yeah.
I'm just setting the table with respect to this snowstorm. Unless you want to go immediately to the South Pacific and look at the hurricane or...
Well, as you probably can guess, I'm uninterested in that.
All right, then come on up. You can start this off if you like. Because I wasn't ready to talk about that either. But if you wanted to talk about the current weather, I invite you to...
Okay, I'll do that before you get further along.
Yeah, this is, I'm really just kind of
Okay.
wrapping this up and kind of awaiting your arrival. So
Okay, sorry we were late.
Oh, no, it's okay, that's okay. So,
Okay, great.
come up, John.
I don't have anything prepared, Pete, so if you can just kind of navigate through. We'll start with our normal satellite movie.
Oh, satellite.
It's great to be back. You know, frankly, my sabbatical was an interruption of my fellowship with all of you, and I didn't really like that so much, so I'm glad to be back. Except for Greg. I know he's going to tell me something that I have to argue. Okay. Here's our visible satellite movie. Now, I was telling my class just a minute ago on 100. If you went back, I'd say, well, let's see, I don't want to be too ridiculous about this. Let's go back 70 years. So we're in, what, 1952. And you had some ability to see this surface, this satellite movie, and you had surface analyses, and you had upper level analyses. You would never make a one-day forecast for a legendary snowstorm in southern New England, unless you were just way out there. And I might have been the one who did that, but I don't think you confidently have done it, let's say that. We're in a whole nother era. This discussion that Michael was talking about, this storm has been in the forecast for several days. And the degree of bouncing back and forth has amounted to, will the coast get 3 feet of snow or will it only get 1? And that is unbelievable when you think about it. So here's the setup, as much as one can even imagine it as a setup. The satellite, this is the visible. So you can't see any circulation feature at all in the lower troposphere, as kind of looking through some higher level clouds. It is apparent that there's a really strong jet stream, a tropical, subtropical jet stream. It even seems like there's a little bit of rotation somewhere here down south of St. Louis in the Carbondale area in Illinois. So those are a few of the things that stand out to me when I look at the satellite movie today. Snow in the Intermountain West, not much going on along the Pacific coast itself. There's a nice storm at the end of the Aleutians, but it's nothing really that we should detract our attention from what's going to begin to develop over here. So let's go, Pete, to the, let's look at the radar summary next. So I think you can see some of these elements that I was mentioning, maybe particularly something that appears to have some structure here on the Indiana-Illinois border in the radar. I'm not sure I see any rotation there, but the combination of what I thought I saw on the satellite and what I see, especially in this leading couple of bands, makes me think there's something going on there. We're going to want to look at upper levels and see if there's any sort of structure that one can see under the radar hood, I guess, as it were. And then some precipitation erupting over the state of Rhode Island, encompassing the entire state of Rhode Island. In fact, it's huge. And making its way into the southeastern part of Massachusetts. Just a harbinger. These might be the stray flurries that I remember from Monday morning, February 5th, 1978. we had the chance for this massive blizzard, and it was in the news for a couple of days before that. And it was just 2 weeks after a really legendary snowstorm on the 20th of January, 78. And that morning, I'm sitting in school, I think I was in 8th grade or maybe 7th grade, looking out the window, and there were a few flurries, and they stopped at 10:30. And I thought, damn it, out to sea again. Wrong. It was just like a prelude that had nothing to do with the main blizzard. That was still coming, and it was great. So maybe the same thing's happening to some young school kids here in southeastern Massachusetts this morning. I hope that I'm right. Then kind of scattered clouds, precipitation, I mean, all the way from Albany down to about Atlanta. And we'll see on a surface map how much of this is snow. It looks like the northern fraction of it is at least snow. Maybe some of this stuff in the higher terrain of western Virginia and western North Carolina is as well. This is definitely liquid precipitation off the coast. And we're too far, we don't see anything going on here in the northern end of the Bahamas, but that's where I think there's currently a minuscule, sort of hardly detectable region of low pressure at the surface. It doesn't, because of the radar's range restrictions, we can't see whether there's any circulation associated with
Point out a
it.
couple things on that.
Yeah.
First of all, it's interesting in Lake Michigan, you can see that shore parallel band.
Yeah, beautiful.
And coming off in Chicago, which was what was causing their blizzard, so it's a lake effect.
Oh, man.
And that's why Chicago got that heavy snow at the end of it. This is something more typical in Gary, Indiana, but it's happening in Chicago. The other thing that I thought was quite interesting is this massive amount of snow over the Appalachians there, all lined up with the mountain range.
Yeah.
It's all over graphic snow.
Yeah.
It's really driven by the local terrain. And
Yeah, that's true. This does almost look like a topographic map, or when you fly over Pennsylvania, you can see the seesaw nature of the topography. I didn't think of that. That's true. It's amazing.
so most of what we're seeing on here, as you're sort of suggesting, is not due to what's coming.
Yeah, right. Isn't that just amazing? Man. So, there's young people all the way up and down the East Coast from DC northward probably thinking, this is the beginning of the snow. And they're wrong. The best is yet to come for some of those places, and disappointment for many others. So I don't want to minimize that. So that's a good point, Greg. That's especially true along the whole spine of the Appalachians today. And this is where all the action is, both now and perhaps in the near future. There doesn't seem to be much of anything going on precipitation-wise across the western 2/3 or so of the United States. So attention is focused on what's going on along the Atlantic seaboard. So can we look, Pete, at the surface map first, before we go to the 500 mile map? We'll take that big view and just kind of go around the country. Okay, we'll start with Madison. We were 4 degrees at my house, I think, this morning. I don't know what the airport was. I guess it was closer to 0. Usually is. But the other day, minus 17 at the airport was, I had minus 11 at my house. So usually there's a bigger difference between the two. And so that was a darn cold morning. Brutally cold, in fact. So look at all the light snow across Pennsylvania. The whole state has light snow. There's a little bit in New York City. There's some in Providence, 34 over 21. So that's great. People are thinking it's a big event. It's not. Moderate snow in Albany, or not in Albany. Is that Schenectady?
No, that's,
Poughkeepsie?
Poughkeepsie, yeah, Poughkeepsie down in the Panhandle. And then snow goes as far south as Frederick, Maryland. It's not snowing in DC.
Hagerstown.
Yeah, in the western part of the higher terrain in Maryland. So nothing along the coast, but that's about where the snow stops until you get into the higher terrain of West Virginia. So it's snowing all the way into there. Some light snow also over southern Indiana. So Evansville's snowing, not in Kentucky, a little bit here on the border, some there at Cincinnati. So it's snowing in a bunch of different places, even to the west. So maybe that's the feature we want to see at upper levels, hopefully. We'll see some resolution to that. And otherwise quite cold in the Great Lakes states, as we all know. But it's been a seesaw. Yesterday was a nice day, and then today it's down again into the single digits this morning. On the west coast, or further, I should just say further west, a little bit of snow here and there in places like the high terrain of Colorado. I don't know if that's Leadville or not, but it's pretty cold there. It's not cold anywhere else. What is that? Fog or visibility obscure or something at Seattle, south of Seattle. So not much going on as was suggested by the radar summary in the western 2/3 of the United States. And really, to be honest, not bitterly cold air anywhere, even in Ontario and Quebec. And you have to go even into northern Saskatchewan. I mean, this is nearly Churchill, in Manitoba, Churchill, Manitoba, further north, places south of that are only minus 13, it's not that bad. Minus 17 at Churchill, we had that the other day, come on, give me a break. So, okay. Now, let's take a look at 500 millibar map first.
Oh, no.
Hey, I don't know what he did, but he's Pete. He always figures something out. This is 12Z this morning. Oh, this looks just like, this is the anniversary of the Challenger explosion in 1986. And this looked like the map on the 26th of January 1986. It was 2 days later that the really deep cold air made its way all the way down and did that damage. So this is a really interesting, and we had a big event brewing on the East Coast then. That was during the Gale experiment. It didn't come off. It was too bad. It just didn't really take off. That was the one chance I thought we had, but we didn't get it. So very similar, climatological pattern actually, when one thinks about it. Here is the upper level cold anomaly. It's like minus 35 at Des Moines, minus 34 at, I guess it's not an anomaly, it's colder in the north. I thought it was a local anomaly. But there's a strong curvature maxima right about in that region that spread the snow over parts of Ohio, Indiana, and Illinois that we saw just a minute ago. So there's some connection to, you know, the upper level flow to that feature in the radar and then in the widespread snow that's connected. That, I suppose, is probably a portion of the upper level wave structure that's going to be part of what develops this storm. And I guess, Michael, you heard a lot this week about whether or not we can trust the observations from Canada and all that, and how that has a function in resolving, you know, this thing a day or so later. But this is a pretty decent network of upper level sites, and they're fairly, I suppose, fairly reliable. So if you're going to have something emerge out of a northerly flow in Canada, I'd rather it be at this longitude than further over in Ontario, because it's a little bit better resolved. So,
If I might, I also just recently saw something kind of on the same note about the observation network and impacts.
Yeah.
I was kind of thought the same thing about the radiosonde being a primary data assimilation driver, but apparently now it's so made up by satellite data that radiosondes only account for about 10% of forecast impacts.
is that right?
Yeah, so the network density is almost negligible now relative to satellite observations.
I like that. And in Kelvin, that means observations of the winds, temperatures, and so on as well. So to some degree, the temperature retrievals are dependent on the radiosonde. So it's nice to have this corridor be where you want to get your temperatures, right, than this one.
Right.
But the winds are pretty good from the satellite. So yeah, that's interesting. Great.
I point out that low pressure up, with the Hudson Bay there.
Yeah.
North of it. Yeah, that is the polar vortex. It goes up into the stratosphere. It goes right up 30 kilometers.
And here's some evidence that immediately supports this idea. I don't know if I've ever seen minus 50 at 500 millibars, and here at minus 48.
So
So
what
it's
this
not
is,
cold.
normally the polar vortex is kind of a axisymmetric vortex around 65 degrees. It's centered at the pole, but this protrusion is a little nodule coming off of it that's forming a separate, at lower levels, it forms a vortex. That's a closed vortex at 500 millibars. But if you go up, it's an open vortex centered at the pole, but this is a little wave. And there's two waves around the globe off of it, but each one of those waves is associated with some kind of a jet interaction from the south, from the subtropical or tropospheric jets. And the tropospheric jet right now is starting to interact with that coming up from the south. And this is what's going to create this sudden drop in pressure at the surface of the storm when these jets come together. They haven't quite come together yet, but they're on the verge of it. And what's interesting to me is why this nodule has come to the south. Why is this polar vortex sitting, a protrusion off of the main polar vortex?
Yeah.
Why is it low levels has it migrated to the southwest? That's before what's going to happen from the subtropical jets, before that interaction occurs. Once that interaction occurs and the two air masses couple up, then we get this tremendous release of potential energy that's about to occur, and that's what's going to happen with the storm on the East Coast.
Okay.
Yeah. John, I was going to just add another thing back to Kelton's point and your earlier point about the observational network. So while it's true we have, it's really well sampled from satellites, from radiosondes, the really interesting thing about this event, and we'll talk a little bit about this when we get to the forecast discussion, is the fact that there's been so much variability in the placement of this cyclone offshore. And you were saying that, you know, the question was, is it going to be 2 or 3 feet of snow versus 1? But in some places, it was 2 or 3 feet versus an inch.
Oh, yeah, that's right. Further west, definitely.
Right, on the
Yep.
western edge of this.
Yep.
And so we're in a situation which is, I would say, somewhat unusual. You don't see this often, where you're within a day, day and a half of an event, and there's still significant, there has been significant uncertainty. I think it's collapsed a little bit, so the
Yeah.
uncertainty's gotten much more narrow. But this is a really fascinating problem with predictability.
I agree. I think there's so many dimensions to this storm. And Greg brought up some that I would not of course, have thought of, and then the predictability elements are really interesting. And the flow is not strongly deformative either. And so it's going to be really hot. That's one of the things we've been talking about this week, is that even in all the forecasts, one thing they've shared is they have not been able to develop anything like an occluded quadrant to this cyclone, even though the cyclone gets down to, in some of the simulations, down to 959. Because the stretching is so intense from southwest to northeast that you just can't wrap anything up in that. But the atmosphere is likely to show us that it doesn't matter. You can still produce extraordinary amounts of precipitation if all you're relying on is horizontal frontogenesis and a strong stretching deformation region, and as long as you get a pretty decent development as well. So I want to see how this, and we won't do it right away, I want to see how this manifests as an upper vorticity feature, and look a little bit also at the vertical motion diagnostics associated with just this feature. And then we're going to have to go higher, because it doesn't seem at 500 millibars there's anything down here. And here we saw in the satellite picture this streaming high clouds, so there's got to be a strong jet to the south there. And another way perhaps to think of this development is some sort of interaction, and I don't know the details, between this feature emerging out of northwesterly flow, which I'll highlight is a region characterized by warm advection and cyclonic shear. That's ridge building, or that's ridge building this way. And that probably intensifies the vorticity, especially the curvature vorticity down at the end here. So that's, I think, happening simultaneously with whatever's going on here. So my guess is if we watch the sequence of 500 millibar vorticity charts, this thing gets more and more intense, while it's still well to the west. And I think it's a function of the ridge building that's going on in that warm advection region.
John, I think Ian's got a...
Oh, sorry.
Yeah, I was just going to point out, going off the lake effect discussion, that there's some evidence here for the cross-scale interaction of the idea that this trough axis is directly west of Chicago. The Arctic subsidence hasn't set in yet, so the boundary layer doesn't have a capping inversion. Like, if you look at a sounding, the vertical wind shear is low, and the, theta E goes straight up into the... And so these are the kind of warnings that you don't want to be driving on Lakeshore Drive.
Yeah, you're definitely right. The shear is really weak right over the lake axis. That's interesting. Yeah, that's right. That's a good point.
And there's probably, synoptic scale ascent is probably doing some of the work to keep that Arctic inversion out of the way. Let the band just grow into the vertically, and so as long as we have the land recirculation going over the lake, I don't see any reason why the band can't just keep going up.
Yeah, that could be. That's a really good point. It's kind of found a little, what do they call it, a chink in the armor of the whole upper structure, yeah. Okay, let's, before we go to 300, let's go down and see what the thermal structure is. So let's go to 850, if we could, Pete. So, somebody turned this in, yeah. Okay, there's our big vortex, and it's got a structure all the way down to 850, so it's pretty deep. There's not really any well-organized thermal structure except up in western Canada. That's pretty nice. That's a pretty intense paraclinic zone. That's 10, 15, 20 degrees C across that. I thought it might extend a little further southward into Minnesota, maybe Iowa, but not quite. It kind of gets eroded in here, in the face of northwesterly flow. So it's not because it's being warmed up by subsidence, I don't think. It's just not structured well. And then also, here's the first time you see any evidence at all of a geopotential height minimum off of the Florida-Georgia coast, and that's just on the northern tip of the Bahamas. So that's a feature that stands to be a player in the development. I think it's probably the main player, right, when it comes along. So being at this southerly latitude makes one think that there's got to be something at least assisting the sustenance of this thing.
Right.
So let's
So
go
I have
to...
a question.
Yeah.
Why do you think that pressure is dropping now?
Well, that's what I was just going to interrogate. I don't know.
But also, I want to just add another thing
But
about
I'll
this.
make a guess.
Sorry to interrupt, but this is really interesting, is that if you look at this map and I ask you, what do you think about, you had not looked at any numerical weather prediction model forecast, would you be contemplating at this point that the next day or so there would be a significant cyclone off the East Coast?
No, I would not.
And I think, for me, I would also probably not say that, because I don't think, the baroclinicity is not, at least at this level, and that's an important point, at 850 millibars off the southeast coast of the United States, that's kind of run-of-the-mill baroclinicity. It's nothing super.
16 degrees between Hatteras and Pittsburgh. That's not that much.
Yeah. Kelton?
I have a question regarding that note, though. Correct me since my understanding must be wrong, but I thought that part of the coast where Florida, Georgia, South Carolina, that curvature, I thought that was known as like a relatively common cyclogenesis
Yes.
spot.
Yeah, it is.
Type of-
It is,
this
yeah.
type of pattern.
Yeah.
And something else that jumps out with that is, with that in mind, if you look at the Little Rock observation down to Jackson, down into Mississippi, and you kind of see this really intense kink right there in the
Yeah, right in
in the
there.
flow field.
Yep.
That seems indicative of a wave starting to move towards that curved region of the coast.
Right.
Yeah.
Excellent point.
Yeah.
So the curvature of the coast, what it does is it allows you, particularly if you have a cold air outbreak, it allows for the formation of a local maximum and diabatic heating surface fluxes right off the southeast coast, around Savannah or whatever. And so that's going to give you, well, Laplacian of diabatic heating is going to give you height falls and then spin up of vorticities. That's one element. But the thing that's, and the other point that you mentioned, from Little Rock southward toward New Orleans, there is some frontogenesis going on there. There's certainly being an intensification of that, but the cold air also, the cold advection that's seen over Arkansas is also another feature that, for that upper trough, it's going to help deepen the upper trough a little bit more.
Yeah, so that's a really good point. The concavity of the coast here is a very important factor under certain circumstances like this one. Yeah.
You know, it's sort of clear to me when I look at these jet streams that I always look at, where this interaction is beginning, there's a large quasi-geostrogically driven divergence aloft, which is second mass out of that column of air right around there.
Even right now.
Right now. And I think that's pulling the pressure down.
Yeah, that one, I was gonna go and see if we could make a guess about that without going to the final answer, but that was exactly where I was going. Is thinking that there's gotta be some sort of jet-induced type circulation there, and then you can go and see whether or not that's right.
Let's take a look.
So let's go to 300 millibars and keep our eyes off the coast. So here's the region where we have these pressure falls, and one sees this kind of slightly cyclonically curved jet. There's an upper trough axis at 300 about like that. And this is kind of a stubby little jetlet, but this is the exit region, so the ascent from just the along flow speed change is over here, the descent's over here. So it's a little bit hard to really understand that, in my opinion. Meanwhile, this feature here, coming in the northerly flow, puts a little bit of ascent right about this place because, well, the jet exits maybe here, so maybe over Iowa. And that corresponds nicely to what we saw on the radar. So this one is a little bit more complicated than would meet the first glance, in my opinion. Let's see what it looks like at 200. Then the jet's just broader. I mean, it's just, because this is now I bet you this is kind of the top of the, this is the subtropical jet, or polar jet, and then this is the broader subtropical jet to the south or something like that. So that's my guess, but you could determine that with some
Point
further
something else out on
analysis.
this. What I see on that, I see that gray area going up to the Hudson Bay. See that extension?
This here?
Yeah. I think that's a reflection of the polar nature of the lock. That there's some extension downward already.
Should it get stronger at 100?
Probably would.
Let's see.
Let's see. Maybe
It's still there, it doesn't connect
there.
down to the south. It's still there.
but I think it's just a reflection of the, which is out much higher. You have to go up
Yeah.
even 50 millibars around to really see.
Well, the last thing I'd like to do, Pete, if we could go to my Omega page, we'll just look at 1 or 2 times only. Because I don't want to go too far at all into the forecast.
Go ahead and then under what it was.
I think that you do.
Yeah,
Right there, yeah, that's the one, too. That's perfect. Okay, let's take a look at the 0 hour. This is from 0 Z. We don't want to do that. We're going to do a 12 hours. We'll just look at a forecast. That's okay. We'll do a 12-hour forecast. I'm not sure that I'm going to have the other one in yet. So this is a forecast from last night valid this morning. At the same time, we were looking at the 500 millibar map, 700 millibar omega, it's rising in yellow and sinking in blue. And it's 500 to 900 thickness is the dotted lines. So broad ascent, we're not seeing any of the meso sort of features except maybe there's a little hint of something there at this time. So that's just telling you that the broad scale trough is giving you ascent to the east and descent to the west. Innocuous looking, for sure. I have other levels, but I don't have them on my webpage, so it would be interesting to be able to do that. Let's go those 6 hours in advance, so it looks more like right now. And all that's really showing is a little bit of an intensification of this couplet, but a translation to the east. I think the broad picture from this perspective, this dynamical perspective, is about the same. So no particular insights here. We could jump ahead to 48 hours, but I'm not going to do that to Michael. It's available if we want to.
Right, but is that
it's pretty robust.
Sorry, John, but is that suggesting even at this point that we would be already seeing vortex stretching occurring over the southeast?
Yeah, divorced from the current minimum, local minimum of the geopotential height. It's really focusing things here. That's right. That's what it looks like. Yep,
Okay.
that's exactly how I interpret that. And
So-
this is consistent with what we were just seeing, well, it was 12Z 850 map, but the subsidence back behind in the cold advection region, that's sharpening the wave too.
So if we can, I mean, what's the next increment? Is it 6 hours?
6 hours, yeah.
Let's just go to 6 hours, because that might lead nicely into the beginning of the...
Yeah, much more intense. These are at the same contour interval all the time. So this couplet's getting really strong. And you're starting to see, you know, the maximum column stretching is going on right here.
Mhm.
Whatever that means as we keep on debating. But it's definitely right there. Yeah.
Okay. So, yeah, so a prediction someone might make, or a diagnosis someone might make at this time, is that later this afternoon or evening, we should begin seeing height falls or pressure falls off the, I'm gonna probably move this a bit more offshore, but off the Carolina coast.
Yeah.
That's where we should see the biggest pressure
Yeah,
falls.
that's right. The
Okay.
age-old story, if you're up in Boston, what's happening at Wallops Island?
Yeah.
That's right where we're looking at, you know, you want to know that.
So just a little tidbit on that. Right now, the NASA Impacts project is going on out of Wallops. So they're going to fly tomorrow, the P3 AR2, this event. So, and extra soundings, so anyone who wants to keep track, they're posting everything on their field catalog, and it's super exciting.
I'm really jealous.
Yeah.
I don't even know how that happened without me knowing about it.
Wait, what is that study, the impacts?
It's to look at snow banding.
Oh, okay.
So really heavy microphysics focus. They have a mobile radar at Stony Brook that will be deployed on really heavy aircraft. And it's year 2 of 3. So,
They even did that right.
yeah. So anyway, it's going to be super exciting to
Yeah.
see the early
No
quick
doubt,
notes from that.
no
Yeah.
doubt.
Yeah.
That's the place to be. When you see the column, you probably could see the column stretch and the spin up going on at Wallops Island.
Yeah, yeah.
That's going to be exciting.
Yep.
Okay.
Okay, thanks, Michael.
Thank you, John. Okay, let's go to pivotal, and we'll go to,
Yeah.
we'll go to GFS first, but we'll look at a couple different ones. GFS,
Yeah.
and we're gonna move away from this, we're gonna go to just a single image, please. And we'll also focus on the, look at the national map first. Please, Pete, thank you. And we'll go to sea level up to the surface, pressure representation. Great. Okay, so this is the GFS forecast for 18Z this afternoon. Shows that area of light precipitation that we saw in the observations that John had just gone over. The feature that I'd like to note also is that you can see that strong cold advection along in the south central part of the United States and the central Gulf of Mexico. And then this broad area of lower pressure, cyclonic vorticity, we saw in the radar that as far as it could extend offshore, we could see there were some showers and maybe even a few thunderstorms, but some convective precipitation, perhaps, certainly precipitation is forecast by the model in this area south of Cape Hatteras. Again, this is a very amorphous structure in terms of the broad cyclonic circulation. There's a broad geostrophic vorticity maxima just south, forecast to be just south of Cape Hatteras. Another one way out west, east of the Bahamas, and another one closer in near Cape Canaveral, but that's not going to be too much of a focus. So let's go ahead.
Can we stay just for a second, Michael? The increment between 1014 and 1016 over the Carolinas is exactly where the column stretching would be. So go over land.
Right over
See
here.
how 1016 goes all the way around this?
Yeah,
kind
oh,
of-
yeah, exactly.
Yeah,
That's a
right.
nice signature.
Yeah.
And we're gonna see this also in the upcoming slides, that there is this tendency for the pressures to remain low in advance of this deepening trough. We can see it in the thickness field. But this is really something that's kind of interesting. We have this feature out here, we have forcing for development here, but perhaps because of the extreme stability and much lower, weaker stability offshore, we don't see much happening here. We'll see
Yeah.
some evidence of that, and we're gonna look at the stretching terms of vorticity equation in a little bit, just to see how that's manifest for this developing cyclone. So let's go ahead.
And I may be imagining things,
Yeah.
but the 534 to 540 thickness corridor over Virginia, Kentucky, a little further north where it's snowing, that's starting to get a little bit of a concave bow in it, and that's indicative perhaps of the elongate stroke Q vector forcing there.
Okay, so this is,
Ending it
things
up.
are getting primed.
Yeah.
It's consistent with the Omega diagnostic that you had. So pieces are coming together, the elements are coming together, the wheels are in motion.
Wheels are in motion, yeah.
To begin developing. So let's go ahead, 3 hours. And what you'll notice is, again, in this forecast, the pressures have fallen considerably offshore, where the greatest pressure falls up in here, just east of Cape Hatteras. Notice the increase in curvature of the isobars, that surface geostrophic vorticity beginning to spin up. But also notice that there is really, these are intense precipitation turrets, if you will. This may be convective precipitation. I haven't looked at the difference between the convective and non-convective, but a lot of models are forecasting this very not broad stratiform-like precipitation fields, but really these big blow-ups of strong, intense vertical motion, which also shows up as production of vorticity at the surface as well, which will also be of importance. So we see this initial with pressure falls here, which is consistent with John's diagnostic, but mostly, again, offshore ahead of the upper trough. We still have a significant upper trough to the west, but also even over South Carolina, you can see this lingering trough with another geostrophic vorticity maximum just in the far northwestern corner of South Carolina. Let's go ahead another.
It seems on there that the strongest ascent is where that precipitation is, right?
Right. I would definitely agree with that.
Yeah.
But there is ascent here that's associated with the upper trough. So this development here, I don't think is purely associated with the upper trough.
But it looks like air is racing forward
Mhm.
on the eastern side of that wall, and it goes up the isentropic lift
Right.
right there. And that's what's causing the increase.
There's warm advection over here. Another thing to note is, and I wish we could probably bring this up at some point, the SSTs or SST anomalies are, I think, running 2 or 3 degrees warmer just offshore. So it's going to add some additional fuel to the fire. Also, that also implies that the lower tropospheric baroclinicity, which we didn't see much of at 850 millibars, probably a little bit stronger at 925. It's really intense in a shallow layer offshore.
This is actually reminiscent of Louis Uccellini's PhD thesis back in the 70s, where he discussed a low-level jet formed by the quasi-geostrophic circulation, creating large isentropic lift on the eastern side of the developing
Cycle.
system.
It's interesting. All those mechanisms are working. We can even see them more visibly in today's NWP model.
But I think that's tracing out the quasi-geostrophic circulation right there.
Right here.
Yeah, it's racing forward right there over the isentropic lift. That's causing that band of precipitation, almost a north-south wind going on.
So it could be we have just enough of a weak cyclonic circulation that's developed at low levels, a very shallow one, that it has strong or southerly flow, which is allowing us to get this PG forcing for ascent.
But the southerly flow doesn't seem to be indicating that it's going around that low. It's all driven by the upper level pattern, so it's just flow racing north at that point because of the larger scale
Yeah, there's
pattern.
no way it can wrap up.
Right.
Yeah.
No way that can happen.
But the low is just it's not the cause, it's just an effect
Right.
at this point.
So let's continue. Let's watch the development of this. This is really, again, pretty fascinating. So we go ahead another 3 hours. We've lost another 4 millibars. We're looking at millibar an hour already. More intense precipitation, more of a thermal wave has now been created, but you still have this lingering trough that's back across North Carolina and South Carolina. And let's continue stepping ahead. Precipitation, beginning to break out from Roanoke through DC and northeastern Maryland. Kind of lost another, 5 or 6 millibars, 996. Trough still extends back here, and you can even see in the thickness field, there's also some evidence of this just trough-like feature that still lingers back here. If you're looking at this and thinking, well, where are we going to expect to see the most significant vertical motions associated with upper trough? I would bet John's Diagnostics would, even though they showed it broadly ahead of this upper trough, back over the southeastern United States, this is probably still forcing for ascent back across near the southeast coast of the United States. We're down to 996. Again, pressures are falling rapidly, precipitation's beginning to expand associated with storm. Let's go ahead another 3 hours.
You know, it's almost certain that the forcing for strongest lift is to the west of the cyclone center at
Yeah.
all of these times. How far west is the question.
Right.
That's keeping it on the coast.
Exactly. So we have this forcing for ascent here, which is helping to spin up vorticity. You would think trying to spin up vorticity back here. The cyclone is here, so it can't really get too far out. It's being sort of held in place by this
Yeah.
forcing, this sucking air, if you will, air out of the column just to its west and south. By, this is midnight tonight, our time, 1 o'clock in the East Coast time, heavy snow just offshore, so people probably lamenting that. But then, and even just south of Long Island, you know, that's where most of the heaviest precipitation is in this particular forecast. But we'll see that there's some differences, and we'll hopefully be able to tease them out. We'll look at a few other diagnostics. Right now, we're just kind of looking, describing what we see in this development phase. Let's go ahead another 3 hours. It's down to 990. 3 hours later, 7 millibars in 3 hours. And now you're beginning to see this cyclone apparently beginning to split a little bit. Two minima in sea level pressure. Okay, one that's very closer to where the forcing is for ascent, the other one near the heaviest precipitation, which might be more convective in nature relative to what's happening just to the east. And what's happening, and we'll see this both in, again, a diagnostic I'll show in a second, with the GFS, is that when we have this really strong vertical motion here, perhaps convectively driven, that's generating vorticity and potential vorticity in the lower troposphere. Here where we have the ascent occurring as well is generating lower tropospheric vorticity, maybe at a smaller level. And these are going to begin to rotate around one another. And I think that's the interplay between the lower tropospheric vorticity structures that are being developed during this time period. Remember this time, this is at 21 hours. Is probably one of the reasons I think there's been lots of disparity with the track of the cyclone. I don't think it has a lot to do in the last few days with what was going on upstream in the radiosonde network and things like that I would normally appeal to and look carefully at. And I haven't looked carefully at for this particular event, so I may be entirely wrong. But my speculation is that it's what's going on these really small scales and how it gets resolved, which vorticity feature that's being generated at low levels, and how they rotate this Fujiwara type of effect around one another is going to lead to where this final upper trough interaction with the lower tropospheric vorticity is going to lead to where the cyclone is going to move. If I said that clearly enough.
I think that's a good theory. I mean, it also allows for the possibility that too many cooks spoil the soup, you know? You can short circuit sometimes when there's so many elements
right.
that are involved at that last stage, and that could be another reason why there's just been a bouncing back and forth
Yes, it is.
in intensity.
I was just gonna ask, at what point, and can the western vorticity structure divorce itself from the upper level forcing for ascent? I mean, there's heavy snowfall, there must be some sort of dieback generation occurring too. But how
Right.
much can it really rotate away and divorce itself from the upper levels?
Well, I think part of it's going to be how strong is the vorticity that's much further to the east. And we'll see in the forecast that there's sort of a dumbbelling type of effect. This vorticity, we can look at 850 millibar vorticity. You'll see this kind of rotate, these kind of rotating in this fashion around one another, which keeps it still in the vicinity of the upper troposphere forcing for ascent. So I don't think it's going to be able to totally divorce itself. But the other interesting thing is, as we talked about in 452-751, about this, you know, this notion from the vorticity equation, the dominant term for synoptic scale motions is the stretching term. It sort of takes vorticity to make vorticity. You already have a lot of vorticity being generated here. There is vorticity here, geostrophic vorticity. I mean, I don't want to say there's a lot more vorticity here because there's convection over it. We can actually look at the vorticity distribution. But that forcing is going to be preferred in regions where we already have large values of vorticity. And so whichever one's feeling that the most is going to be the one that's going to be able to grow.
I see that anticyclone over east from Canada,
Yeah.
there, which is a requirement for an East Coast snowstorm. We always,
Right.
we usually look for that, but
This isn't a good one, in my mind.
it's a good one?
It's not a good one.
It's not a good one. But what I'm wondering about it is that anticyclone building as this low deepens so that it's really the place where the mass is going? When you suck mass out of the column where the low is that building that anticyclone up there? Is it commensurate with the deepening? And that's forming, because I don't remember that in the earlier maps, maybe it was that.
Right, we can just quickly go back to 6 hours and see this is what 10:36 earlier. And so it's intensified a little bit, 10:30 or so, we go forward in time, but it's like 12 hours on the forecast, or 15 hours, please. 10:33. The difference in pressures here are certainly definitely increasing, but this is not increasing in pressure as much as this is decreasing.
Well, it's a big area.
Yeah, it's a big area. But I wonder, what's the appropriate box to do this calculation if you wanted to do a budget, mass budget for this? But let's go ahead to 24 hours, please. At that point, again, you see this sort of elliptical structure that's associated with this deep green cyclone, now down to 982. Really strong winds along southeastern New England, right along the Delaware coast. We'll look at 500 millibar pattern. The upper trough is really in a nice location relative to ultimately deep. In fact, let's look at 500 millibar vorticity at this point. Cyclone center is south of Cape Cod, east of Ocean City, Maryland. So roughly right about this area. I think this is probably a good location to be downstream of for development broadly as this vorticity maximum begins to round the coast. Also want to watch the time as we have a couple other elements, I think, so the simulation that he's going to describe in a little bit. So let's also look at 850 millibars, please, feet vorticity. And then we're going to look at some things on JMTech. So let's go back to 18 hours and just step forward in time. So you see these vorticity maxima that are really clustered around this broad area of minimum and geopotential just off the east coast. And we go ahead 3 hours. Just watch how they kind of evolve over time.
How robust are those? Are they appear in every forecast the same?
They're similar in a lot of the different forecasts. Not in every forecast. We can look at the NAM in a second. Let's go to 24 hours for just one more look. They're not all the same. And the structure, if we were to switch models to the NAM, the North American model, over there, right there, Pete. Some similar structure, except instead of having those 3, we have these 2 with this blob. And we step ahead again at 27 hours. Again, you see this notion of them kind of rotating around one another. And so I think it's how this vorticity gets organized is going to be a big story for how close to the coast this is going to be. Given that there's still intense forcing that was upstream of it, I think if there's going to be any significant error in this forecast, that this whole pattern might be further to the west than it currently is. So Pete, if we could stop this for a second and go to the JMTech, go to the terminal window. If there are questions or comments, please feel free.
I'll just say this, Michael, I agree with your last point in the sense that the fountain of air that's rising as forced by the upper wave isn't moving along. It's not feeling the effect of that eastern vorticity maximum. The low-level vorticity, it produces this, but the factory stays in the same place. And that makes me think that its permanence is going to win out. If I had to lay a bet right now, I'd say this thing stays on the coast. It doesn't go out to sea. I think I agree with you on that.
Yeah,
And that's
so,
my reason why.
And here's the diagnostic. This is from one model, so it's going to have to be self-consistent. Go to GD plot and type, click on that GD plot, and then run. And that map is going to show up behind here. And then type semicolon S to step ahead one time. You can remember, make this window smaller, please. Semicolon S, yeah, will allow us even smaller so you can see the. So this is the beginning of the run, and then if you do semicolon L and let it loop, first of all, you can see what I'm plotting here is the product, or minus the product of the absolute vorticity and the divergence. So this is a term that describes the Lagrangian time rate of change of vorticity. Plotted over here is the actual vorticity, and the light contours, the yellow contours just show the orientation of the 500 millibar upper trough. As you can see, that even at the very beginning of this model run, 6 hours in, we're already getting significant vortex stretching occurring in the vicinity of this minimum and sea level pressure, but that it's getting, we're getting a elongation of the vorticity over time where we get the strongest forcing, right? So we have these elements where the forcing is going to be, it takes vorticity to make vorticity, so we already have vorticity maxima. we're getting vorticity generated. But you can see that there appears to be some sort of interplay as these rotate around one another, where the vorticity is getting generated. And the white contours of the actual vorticity is at 900 hectopascal. You can see it getting developed and beginning to rotate, and then it finally balls up just south of the New England coast. Wish we had more time to talk about this, but I think that's going to be a crucial element in determining where we get the significant snowfall data. It's going to be just to the left of the track. Please click on this for a moment, stop it, and then type restore wind.set. That works. Okay, and we can run that. This is this is winds at 10-meter winds for both the GFS and for the NAM. If we semicolon S, just a step ahead, and watch the, oops, do it again. Okay, so these should be at the same time. I'm not sure why the first one wasn't there. You can see the emergence of this cyclone center just off the southeast coast of the United States, the GFS. The contours here are the isotachs for the wind. And we need to step ahead and watch the development of this. So these are 10-meter winds. We're getting a strong low-level jet at 20 knots out of the north, just to the north of the cyclone center, just off of the Maryland coast.
That's underneath the warm front, what it is probably, right?
Probably, right.
Yeah.
It has to, yes, it's where it's most unstable, yeah.
Yeah.
So this really weaker. Keep going forward. And you can just watch these really strong winds near the surface, right along the coast. Again, if this were just pushed a little bit further to the west, that would be associated with lots of big problems for the coastal areas. But at the same time, they're going to get significant precipitation. And finally, what about the snowfall amounts? We can look at this and recap this next week in terms of what actually happened. But I'd like to go back to the pivotal for a second and quickly look at snowfall amounts there, and then look at some of the results of the simulation that Isaac Schlussi has done for this. Go down at the bottom, wintertime. Further down, there. And let's get 10 to 1. Unless you want to really have some fun.
No, we don't want Kuchera's
Sorry. So 10 to 1. Click on that, and then let's go to continental, regional. Click on this. Let's go to the Atlantic, and then let's go to 60 hours. By 60 hours, this should be pretty much done. And so for the NAM, there are amounts in here, 17.7 inches or so. Again, the heaviest amounts are well off. In this case, offshore 25. So that's a pretty.
Isn't this less than they were going for yesterday?
It's a little bit. We could also go back and look at prior forecasts, but I want to just first look at GFS. And this is assuming a 10 to 1 ratio, just a flat 10 to 1 ratio. If you don't do that, you'll see bigger numbers. Again, this is just incredible offshore, these amounts, well over 30 inches. But again, a shift to this brings some of this onshore. The ECWF model may be up. These numbers are lower than prior runs, ECW high res, sorry. Go back too quick.
Can you imagine 3 feet of snow accumulating on the deck of these big transport
No,
ships?
no, it's just incredible. With 50 knot wind. With 50 knot
Who
wind.
goes up there and shovels it? I don't think anybody.
Lowest guy on the totem pole.
So this is interesting in these forecasts. Again, this is assuming that 10 to 1 ratio. These have come down probably by about 50% from what we were seeing earlier. If we go back to the 0-0 run of this same model, it changes here.
0-0. Oh, you know.
Michael or John, do you guys have a sense for, would the isobaric component there try to fight the inshore, as in keep the cloud band offshore? The isobaric winds trying to always bring colder air across ice bars towards that low pressure center, and do you think that would directly play into the cloud bands?
Depends on what side of the storm you're on. I guess the isobars are negative ahead and positive in front, so I guess it depends on what time in the storm, if that's something to be concerned about. I don't know.
That's something I have to think a little bit more about. Just a couple last things, and I know we're going to run a little bit late. Here is, this was from Jeff Frame, he put this diagnostic up, this is from the NAM from last night, 3-kilometer NAM, 700 millibars. You're looking at frontogenesis, are the purple contours here. The temperature advection is the shaded pattern here, so nice localized warm advection. We also have a really strong front right here. And this is, again, a different model run, it's from 0Z last night, but this was suggesting a significant band of frontogenesis to the, right along the warm front, north of the warm front, where you'd expect then to see some fairly significant snowfall where this is all snow. And so frontogenesis being a really good diagnostic perhaps of where this significant precipitation is going to occur. Or just a classic QG omega, this localized warm advection is going to be associated with significant upward vertical motion ascent, which is going to contribute to it. We have enough moisture, it's cold enough, so we have a forcing for ascent, and it all seems to be linked nicely with this particular storm. Haven't seen that diagnostic for the more recent runs, but that's something to certainly check out. Isaac, did you want to show a little bit about the run? We have a run here. Isaac Sushi is going to run. If we click on this.
So I mean, just can you refresh the page?
Yeah, you can refresh that. Come on up.
All right. If you want to start with the total snowfall, I guess we can just compare that to what we've been doing here.
First thing at the top.
So essentially, just based off the 0Z GFS data last night, I just did a 9-kilometer outer grid war simulation, and this is 3-kilometer inner grid here over the northeast. So this is the accumulated snowfall map.
Is there a legend? Sorry.
Yes, there's a legend on the bottom. Sorry, the figure got a little big. But you can see it kind of meshes fairly well with what we've been looking at previously on the other snowfall accumulation. So southeast Massachusetts getting hammered there upwards of 20, 24 inches potentially. This is, I'm not sure what the ratio is. I think this is somewhere I don't think this is a straight up 10-to-1 ratio. This is something that the work itself cooks up that does the diagnostic.
And also includes some melting too.
Okay,
so,
excellent. Yeah, so actually what this is the snow depth at hour 48 minus the snow depth at hour 0. So it looks like some pretty impressive snowpack by the end of this event. Pete, do you want to go back real quick? Maybe just take there's just a couple products here. I haven't had a ton of time to delve into the full data set. If you want to go to the Nest max reflectivity, I think that's a kind of fun one to look at. I just want to do the GIF on the far left, right next to the title bar. Sorry, this website's a little just to the right there. Perfect. This website's a little rudimentary, but also here just a loop of the simulated max reflectivity that the work spits out. Just thought it would give us kind of a good idea of where we're expecting to see some of this intense banding. Also, one thing I noted too is you can kind of see almost, and there's been I've seen some tweets about this, almost an eye-like feature occasionally in the cyclone there. I would love to have overlaid this with MSLP, but this is before my coffee this morning. So yeah. I'm not much of a synoptician myself yet, but so I won't comment too much into that. But yeah, do you have any comments?
Yeah, if we go back a quick, do you have a surface pressure map of this? I forgot to.
I don't have one of those
Okay.
yet. Sorry, that was my next thing.
Looking at the 500 millibar vorticity, this is another interesting product. So this is on the larger domain. So this is absolute vorticity everywhere. This is that kind of shredding of the vorticity east of, where the cyclone's developing in this area, which I think is kind of interesting with the, here's our broad upper trough, and this may be just the low inertial stability east of this upper trough, but just how it kind of gets shredded up a little bit. You don't have a nice coherent blob of vorticity, but that may be more a function of just
I didn't
what it
scope
looks
this
like.
at all either, so it's probably.
Yeah, that's a 3-kilometer run.
This is the 9-kilometer
Nine.
domain.
Yeah, it's just high resolution maybe.
Yeah.
Because the delta, the -2 of that gives you the geopotential height, so that's what smooths it out.
And then the last thing is just the jet structure, if we go back there quick. But thanks, Isaac, for
Yeah.
putting this
Yeah,
up.
that's great.
Maybe doing this is at 500 millibars, above 40 knots, every 15 knots contoured. You can see this nice, robust feature coming around.
Go right across the board.
See, it just can't wrap up. It tries, right near the end, it tries to put that little notch in the geopotential height over Maine, but it just can't do it because it's too progressive a flow and the jet's downstream.
Right. And that high that Greg alerted to, it's not in a location really to block the cyclone in and keep it from moving out, so you don't have to block any gas up in the North Atlantic.
Fascinating event.
Can you put up the jet stream maps that I do at some point?
Yeah.
Hey, put that up. from
Thanks, Isaac.
12Z.
Yeah, sure.
I just want to point out what I think is happening. Here's the polar night jet. This goes up to 25 kilometers on this plot, it goes above that. Go to the first frame. So at 12Z, well, you gotta go to 12Z.
Supposed to be run down.
Yeah. We do them early. Okay, this is just most recent. So here's the initial one, subtropical jet going across the south. Here's the polar jet up here. They're kind of connected. But see this notch in the polar night jet up very high. That probably is affected by this interaction that's occurring here with another polar jet. But you see these things coming together early, so step forward. See how this connects up? As this connects up, I think it creates the divergence pattern. It starts drawing, accelerating this polar jet and the subtropical flow of the south. It starts sucking that into there, and that's what's lowering the pressure over here. So go keep stepping forward a little bit. Okay, right here, you see how these connect up in here now? Now this is at 0Z tonight, and this thing is getting going. Now, go forward. Just let it run. Look at that. They connect up, and this thing accelerates into here. This is what's keeping it offshore, because this connection is offshore, and it's basically staying right about here. And this connection's pulling them through. So just animate through this now, Wes. Just turn the animation on. And what you see is these kind of things are happening all along. But you see how when the jet gets close, pieces of it get pulled up into here? And the same thing's happening here. Pieces of it are getting pulled up into here. That's creating this divergence. As you create divergence at the surface, it spins up the cyclone because of convergence and conservation of angular momentum. So I think the low is pretty much a result of these accelerations occurring between the stratosphere and the troposphere a lot. You can show all the quasi-geostrophic stuff that goes with it, but the bottom line is this interaction between the tropospheric flow and this polar night jet are creating these flows. Now this actually represents in Lewis and Palm circulation. There's a massive transport of energy, potential energy from the tropics into the polar regions. And so this is kind of a manifestation of what the Hadley zone really looks like. It's these plumes of air that are drawn from the tropical potential energy that's put up there by tropical convection. These plumes are drawn up, and as they accelerate into this flow, they create weather underneath. And I think it's very much dependent on that. But if you just watch this thing, and we could put up weeks of this, you can see all these connections, and every connection has a big surface effect associated with it. So that's all I want to point out.
Well, thanks, Greg. And that's something that'd be interesting to look at and just trying to identify what's the best diagnostic to link that, or what's the best measure? Is it looking at the velocity potential and how it's pulsing during these interactions, or just the integrated divergence in a box where these interactions are occurring?
That's a good question. I haven't really looked into it. I just noticed that you can see the interactions, and I think they're certainly created with a convergence at the surface. That's why you saw that pressure start to lower. As the subtropical jet started feeling the polar night jet, then there's an acceleration that way, and that's pulling the air from the column off the east coast, because that was a little bit off the coast. And I think that's what's causing the low there. But then there's all the baroclinic effects of the topography and the land versus sea. All those effects get into it to focus where the low is going to be. But the low is really a result of that pulling of the acceleration of the flow into this coupling effect, which is transporting all that energy.
Okay. Well, thanks. Well, thanks, John, for leading the opening of our discussion. Greg, Angela, Kelton, Isaac, and Pete for running this, and everyone in the audience for the questions and the comments that you made, Ian, as well. And so let's just thank our presenters and
I move this to 12:30. 12:15, because there's a class in here right before this, and we don't have a whole lot of time to set up. And there is not a class in here after this, so.
I'd go 12:15.
Yeah, 12:15,
Because
maybe
you've
back
got
to our
class.
old time.
Yeah, I got a
Also.
chance to get back from class, yeah.
If that's
Does anyone
okay.
have to rush at 1? Because this tends to go over. If there's not a class at 1, is there?
There's nothing in here, no.
2:30 is the next class in here. It's a
Right.
matter of if the participants have classes right after this and they need to go.
Right.
If we start at 12:15, we'll probably go until 1:15.
And that's how we used to do it pre-pandemic, it used to start at around 12:15. So, and the other thing is, again, this is informal, so if you have to arrive late or leave early, feel free to do that. This is
Yeah.
not,
No little red check mark next to your name.
Right, all right, thanks, everyone.
Thanks, everybody.